Hello and welcome to Train Signal. You are watching Localization and System Time. When I first started using computers, I never paid much attention to the system time. But when I began my IT career, I started to see the importance of this often overlooked setting. Think of a legal organization that runs a business dependent upon billable hours. In this field, it's important to know when an associate may have begun and completed work on a particular project, and in fact, for many projects. This information will be key in determining revenues. And what about global mantics? With a team of developers working on an application at any given time, it's important to know the time that the last change was made so that newer program files aren't accidentally overwritten. And these are just a couple of examples. We could also talk about the banking, medical, and even law enforcement areas that all rely heavily on having the correct time and location information. So in this lesson, we'll talk about how Linux handles time zone settings and locale information that tells us where in the country or world someone sits. Then we'll move on to how Linux manages the system time and how the network time protocol is used to ensure that your network always has the most accurate time. Let's begin our lesson with time zone settings on the next slide. Linux uses UTC time, which is the time in Greenwich, England, uncorrected for daylight savings time. To translate between UTC and your actual local time, Linux uses the etc local time file. To view the current date and time, you simply use the date command with no options. So Global Mantics has decided to set up an office in New York, and one brave employee is going to go it alone there for a few months. She needs to reset the time zone on her computer from Central Time to Eastern. Note that Eastern would apply to any state that uses Eastern Time, from Ohio to Florida to Maine. To change the time zone, you view the option in User, Share, Zone Info, and pick the one that best applies. Then you delete any existing local time file on your computer, usually in the etc directory. Then you create a symbolic link from the appropriate region option to a new local time file. And you can verify your results again with the date command. Let's fire up a terminal window and give this a try. From Applications, click on System Tools and Terminal. Now we're going to need root privileges, so let's do that first. SU for switch user, and enter your password. Now let's see if we have a local time file already, which we should. Let's type in ls etc local time. And we see that we do indeed have a local time file there. So let's go ahead and delete that. You recall the rm command is used to delete a file. So we're going to delete local time. So we have rm space etc local time. And then we hit enter. Say yes. Now let's see what options we have in our zone info directory. Let's type in ls space user share zone info and hit enter. We can see a list of countries here. We've got America, got some others, and oddly enough we also have US. Let's try taking a look in America. Choose our up arrow to bring the last command back up, and we're going to add in America at the end so we can view the contents of that directory. And hit enter. And from this list it will list cities in all of America, and that's north and south. And you can see here we have New York. And we've got plenty others in alphabetical order. And since our Global Mantics employee is going to New York, we're going to create a new local time file. And we do so again by creating a symbolic link. So let's type in ln-s, that's the command to create a symbolic link. Then we're just going to put in the path, user, share, zone info, America, and we have new _ York, and hit enter. Okay, let's go ahead and minimize the terminal to get that out of the way. And since I don't really sit in New York, let's change the setting back to the original. And I'm going to show you a little trick, much easier than the method that we just used. From the main menu, click on System, then Administration, followed by Date and Time. You have to enter your admin password. And from here, you can not only change the date and time, and you can synchronize the time as well over the network, which we'll talk about shortly. But if you click on the Time Zone tab here, you can use the scroll bar to go up and down and change the setting to anything you like. I want to change it back to Pacific time, so you click on it and just hit OK. If we wanted to change it to something else, we would just go back to System, Administration, Date and Time, go back to Time Zone, and you can change the setting that way. Let's try one more time. System, Administration, Date and Time, Time Zone tab. We'll change back to Pacific, and I also want to note here that you have the option to have the system clock use UTC time right here, and you can check or uncheck that option depending on how you'd like to set it. We'll say OK and close out of there. And yes, this method is easier, but for the purposes of the Linux Plus certification, you should be familiar with the command line method. Now let's go back to the presentation and talk about locales. People all over the world use Linux in a myriad of countries and languages. And thanks to Linux's open source community, the operating system can easily support many languages. So in order to manage language settings, Linux uses locales. For example, in addition to English, you have widely spoken languages like Spanish, French, or Japanese, but you also have options for other languages like Swahili or Malay. This is important because different languages use different formats for date and time, as well as different character sets. So we know that locales essentially tell the computer what country the computer sits in, and what language it should use. You choose your locale by setting environment variables. Locales follow this syntax. Language equals territory.codeset followed by any modifiers. Language is a 2 or 3 character code like EN for English, SP for Spanish, FR for French, etc. Territory is a 2 character code like US, SP, or JP, and this is for countries. Code sets essentially help facilitate data transmission and include the well-known ASCII or American Standard Code for information interchange, which is the oldest encoding technology. Then you also have ISO 8859 and UTF-8. UTF-8 is the latest format, and UTF is short for Unicode Transformation Format. And finally, a modifier can be used to include any locale-specific code. To display your current locale information, you simply use the locale command. To display all options available on your system, add the -A option. So again, if you choose your locale by using environment variables, there are 2 that you should be familiar with. The first is LC_all. The second is lang, L-A-N-G. To change this setting, you use the commands export lang equals and export LC_all equals. And the environment variables again are in all caps. Any change that you make will only be effective for the current session and only applies to the shell and programs that you launch from the shell. To make the change a permanent one, you guessed it, you have to edit a startup script, usually either your bash RC file or etc profile. And sometimes you may run into problems with output because of a locale setting. When this happens, you can try setting the lang to C, which bypasses any locale settings. What if you received information from a coworker in another part of the world that uses a different character encoding set? For instance, a colleague in Russia sent a file with the ISO 8859 code set, and you're currently using UTF-8. Have no fear, you don't have to trash the file. You can use the ICONV program to convert it and change the character encoding. The syntax is simply ICONV space -F followed by the encoding space -T followed by the encoding and then the name of the input file. -F indicates the source encoding and -T indicates the destination encoding or what you'd like to change it to. There's also a ~list option which lists all of the encodings available. Let's switch back to our terminal window and take a look at our locale settings. Now let's try typing in locale and hit enter. And we can see that our locale settings show US and English, particularly for our Lang setting, and we see that LC All isn't necessarily set on our test system. Again, it's an optional setting, but one that's encouraged. And we've got some other variables in here. We've got numeric, we've got address, telephone, measurement, things like that. Now let's type in locale-A. Let's use our up arrow key. We'll do a space -A. Now what you see here in this long list is all of the locale options that are on our system. We've got the 2 character codes and some other information here. So, ready to change the setting? Let's try typing in export space Lang. Again, should be all caps because it's an environment variable. And we're going to say English, but we're just going to use Great Britain's English. So GB dot followed by the encoding, and we're going to say UTF-8. And then let's make sure we type that in correctly. We've got export Lang equals English underscore Great Britain. That's the 2 character country code, and followed by the encoding. And so let's hit enter. Now let's type in the next export command, which is export space, and the next variable, if you recall, is LC, whoops, in all caps, LC underscore all equals, and we're going to use the same encoding, English underscore GB dot UTF-8. Let's make sure we've got that right. Export LC underscore all equals Great Britain English and UTF-8. Let's hit enter. Now try typing in locale again. Hit enter, and we see that instead of US English we now have Great Britain English. Now let's exit the terminal. Just type in exit. First, that exits us from root. Type exit again. Now let's launch a terminal window again. Click on Applications, System Tools, and Terminal. Now let's try typing in locale and hit enter. And we see that we're back to the default setting, which is US English. Now let's say that we have a regular ASCII text file that we want to convert to UTF-8. First, let's type in ls here to get a look at the files that we've got in this directory. And this is a file that we created from one of our earlier lessons, so let's use that. That's fs script. So again, using the program that we just learned about, to do the conversion, we would type in ICONV, V, space -F for the source, and this is an ASCII file, so we'll type in ASCII -T for the destination encoding, which we want to be UTF-8, and then we're going to follow that up with the name of the file, fs script, now fscript.txt, and then we're going to direct the output to a new file that we're going to call fscript.conv.txt. So again, we have the name of the program, ICONV. We have the source encoding, which is ASCII and indicated by -F. We have the destination encoding, UTF-8, as indicated with the -T option. We've got the name of the original file, the output redirection character, and then the name of the new file that we want to create. And then let's hit enter. Now let's type in ls again. and we should see our newly created file, fscript.conv.txt. Now there is no real easy way to verify the encoding type. Some have used the file command or file followed by the document name successfully, and there are some other utilities that I believe may do this as well. But this isn't something that you'll have to worry about for certification purposes. In our lesson on job scheduling, we discovered that cron, anacron, and at are totally reliant upon the system time in order to execute their programs. There are two clocks: the hardware clock, which maintains computer time even when the system is powered off. Then you have the software clock, which is set from the hardware clock when the system boots up. And the software clock is the one Linux relies on to run its programs. When computers weren't networked, or even when they were constrained to one city or even one room, using local time was adequate. However, today's networks are much larger, stretching across city, state, and country borders. And because of this, Linux uses UTC time. Still, each system needs to correctly understand its own time zone. When you type in ls-l, Linux reads the timestamp in UTC and then adds or subtracts the appropriate amount of time to calculate and show your local time. Normally, your local time zone is set during installation, but if for some reason you need to change it, administrators need to understand how to do so. To manually set the software clock, you use the date command, and the syntax is simply date followed by -u, ~UTC, or ~universal to indicate UTC time, or typically you just use the format month, date, hours, minutes, year, .seconds, where there's 2 characters each for month, date, hours, and minutes, and year, but there's also the option for 4 characters for the year. Typing in date with no options will display the current date. Passing a time sets the software clock in a 24-hour format. So December 1st, 2010 at 10 a.m. would look like date space 12 for the month, 01 for the day, 1000 for the time of 10 a.m., followed by 10 for a 2-character year. Let's open a terminal window and take a look at our current software clock settings. Okay, so I've already cleared the window with the clear command. Now let's type in date and hit enter. And we see the current date is Monday, October 18th at 9:07. Now let's use the date command to set the system clock by typing in date space. I'm going to do 12 using the example that was on our presentation. We're going to do 12/01 for the date, December 1st. Then we're going to do 1000 for the time of 10 o'clock. And then we're going to put in a trailing 10 for the year. So again, we've got 12 for the month of December, 01 for the first date, 1000 for 10 o'clock a.m., and then we've got 10 for the year of 2010. And again, optionally, you could put in 20 in front of the 10 for 4-character year. So let's go ahead and hit enter. And as you see, we got an error. And this error tells us that in order to perform this operation, we need root privileges. So let's go ahead and type in SU for switch user and type in our password. Hit enter. Now let's try the command again. Type in date space 12 for the month, 01 for the day, 1000 for the time of 10 o'clock, followed by 10 for the year, and hit enter. And now we see that the date has indeed been changed to December 1st at 10 o'clock, the year 2010. Now let's go back to the presentation and take a look at how to set the hardware clock on the next slide. To set the hardware clock, you use the command hwclock followed by options. And the options are -R or ~show, which displays the hardware clock. Then you've got ~set and ~date equals new date, which are both used to set the hardware clock. You've got ~SYSTOHC, which sets the hardware clock to the software clock, and conversely you have $HCTOSYS, which sets the software clock to the hardware clock. And finally, $UTC treats the hardware clock as storing UTC time. Let's head back to our terminal window and take a look at the HW clock command. Okay, you should still have root privileges, so let's start out by typing in HWCLOCK space -R, which should display our current hardware clock setting. And hit enter. And we see the current time and setting. If we wanted to set the software clock to the hardware clock, we would type in HWCLOCK space, the option is $HCT0SYS, and hit enter. And again, you probably won't notice much of a change. You can just type in HWCLOCK space -R to view the setting again. Okay, let's move on and talk about network time protocol. I remember a common occurrence on my older computers was that gradually the time would get out of sync. Now I could easily reset it, and back then it was little more than an annoyance. But in enterprise situations where file timestamps, cron jobs, statistical, and other time-sensitive information is critical, maintaining a correct system time is imperative. To help maintain network time, there is the network time protocol. Think of it as a pyramid, with the best clocks at the top of the chain or at stratum 0. At this level sits things like atomic clocks. Then at the next layer, the only layer able to directly access stratum 0, you have stratum 1 time servers. These run NTP servers that in turn deliver time to stratum 2 servers, which deliver time to stratum 3, and so on and so on. The NTP server needs a time source with which to sync, and there are a few options. You could either check with your ISP, and this may not be the best option for enterprise customers. Some Linux distributions also provide an NTP server. Another option is public server lists or pools. When setting up an NTP server on your network, you select one system or more to function as dedicated NTP servers. Most distributions come pre-installed with the NTP package, either called NTP, XNTP, NTPD, or XNTPD. The configuration file is called ntp.conf and will contain several options. But most importantly, there are 3 lines that you see on the screen which point to an NTP server. When the local daemon starts, it'll contact all the servers in the configuration file and measure how accurate they are against each other. Then it picks one as the primary time source. If you make changes to the config file, you have to start the daemon by executing the startup script with the now familiar etc init.d space restart command. The ntpq command is used to check the status of NTP. ntpq takes the -p option to display a server listing from the command prompt. ntpq is an interactive program, and using -p, the output will display several fields, the first of which is ref ID, and that shows the server to which each system is synchronized. st shows the stratum, and again remember stratums start at 0, which is the top level, and work their way down from there. Then you have the asterisk sign, which denotes your system's sync machine. Next we have the plus sign, which indicates good times. And finally X and the dash sign denote discarded servers. Let's switch back to our terminal window and take a look at both our configuration file and the NTPQ program. Okay, I've already cleared the screen. Let's first see if we have the NTP daemon installed. Let's type in ls to list the contents of a directory, and we're going to list etc init.d and hit enter. And looking through here, we see that we do have the daemon installed. You see NTPD right here in the third column. Now let's make sure that the daemon is actually running. To do that, we're going to need to restart the daemon. So let's type in etc init.d ntpd space restart. Let's make sure we have that typed in correctly. etc init.d ntpd for the daemon and restart. Alright, so we can see now that it started. Now let's take a look at the configuration file. We'll type in cat to display the contents of a file, and we want to look at etc ntp.conf. And let's hit enter. Let's scroll up a little bit, and here's what we're looking for. Remember when we said that some distributions have their own time servers? We see that confirmed right here with the three options that we have indicating Fedora, Pool, and tp.org. So each of our three server options are pointing to Fedora servers. Okay, let's go back down. Now let's type in ntpq with the -p option to take a look at the status. And again, we have some remote connection information. We have the REFID field that we talked about, the stratum, and some other information that you can see here. Now let's head back to our presentation to cover how to configure NTP clients. Now that the server is configured, it's time to turn our attention to the client machine. The first thing to do is to ensure that your clients point to an internal NTP server and not an outside server. Then you want to make sure that those same clients can in turn act as clients for other machines. To do this, you can either set up a firewall rule, but most likely you'll just edit the ntp.conf configuration file and add the line restrict default ignore. If you make changes to the configuration file, be sure to restart the daemon with etc init.d ntpd space restart. But what if you wanted to do a one-time clock setting change? To do this, you use the command ntpdate. You have to stop the daemon before you can execute the command, and the syntax is ntpdate followed by the host name or IP address. So a typical command might read ntp space myclock.test.com. Another thing to note is though this information is still included in the Linux Plus objectives, ntpdate is actually deprecated and may not be included with your distribution. In that case, you could start ntpd with the -g option, which will let it perform the same function. Let's go back to the terminal and try this out. Okay, first let's shut down the daemon with etc init.d, the name of the daemon ntpd space stop, and hit enter. So now we see that the daemon has been shut down. Let's try out the ntpdate command, see if that works on our system. ntpdate. Now in order to use this, you have to have a server picked out. I'm going to use one of the public NTP servers, and that one is pool.ntp.org. So let's type in that server name and see what happens. And hit enter. Okay, looks like it went out, connected with the server, and adjusted the time accordingly. Let's go ahead though and restart our daemon. Let's use the up arrow key, and now just type in restart. We decided we don't actually want to use that server, so we'll do a restart so that our original settings kick back in. Okay, and we see that the server, we do have a failed command, but don't worry about that as long as the NTP daemon has been started. Now let's head back to the presentation and wrap things up. I hope after this lesson you have a better understanding of just how important it is to ensure that not only your system time, but your location information is properly configured. In this lesson, we learned that Linux time zone settings can be set at both the command line and graphically. Then we talked about locales and how we can change settings to match your users' locations. Next, we covered the two types of Linux system time, hardware and software. And finally, we covered network time protocol configuration, which allows us to sync our network time to outside time servers. Thanks for watching, and I'll see you in the next lesson.